Hey, welcome back to Mr. PL's with Algebra 2. This is Unit 4, Topic 1 SLT1. We're going to start off with a quick review of all the different functions that we've dealt with this year in Algebra 2 and in Algebra 1. This is linear function. Linear functions are functions that are straight. This is an absolute value function. Absolute values look sort of like V's in this case, so it looks like two linear lines connected. And this is an exponential function. It has a horizontal asymptote. That's the reason why I know that it's exponential. Remember, logarithmics have a vertical asymptote. This is quadratic. You can tell by the parabola type shape. This is a square root function, which is, I believe, labeled over here as a radical function. It's square root, and I know that because of the way it looks, whereas cubic root, and I'm going to try to fix this, Rob. All right, welcome back to Mr. PL's with Algebra 2. This is Unit 4, Topic 1, SLT1. We are going to start off with some basic review of all the different types of functions that you have done either this year in Algebra 2 or in Algebra 1. We're just taking a look at these answer choices and identifying what type of function each one of these graphs represents based upon the way it looks. This one's linear function, something you did in Algebra 1, straight line. Absolute value. Absolute values look like two straight lines. Kind of look like a V in this case. Because the absolute value of 5 is 5, and the absolute value of negative 5 is also 5. That's the reason why it looks the way it does. This one is exponential, and the reason I know that is because it has a horizontal asymptote, not a vertical asymptote. This one is quadratic because of the parabola type shape. It's the same on both sides. It's a even function when the vertex is on the y-axis. This one is a square root function because it has an endpoint, so it starts right here and it goes endlessly to the right or to the left. This one is a rational function, and I know that because, well, first of all, it is an odd function. It's a perfect reflection over the origin. You can see that this piece and this piece look exactly the same. This one over here is a cubic function. Cubic looks like this. This is a cubic root function. I know these two look very similar to each other. They're the same thing flipped over the y equals x, flipped over this line. So that means that they are inverses of each other. This one is a logarithmic function, and that's one that we just did in the last topic because it has a vertical asymptote. And we also just did these, actually we did this 2 units ago, and this was last unit. We did trigonometric functions. To be more specific, if I look very closely, I can tell that this one's a sine function, and this one is a cosine function because sine functions always start at the origin, and sine functions always start at the origin, and cosine functions always start at either maximum or minimum. That is, well, technically you can always translate any sine to a cosine. That's just the basic parent function. All right, starting off with each one, I'm going to spend pretty little time on each one of these, but go quickly through them. Linear functions, like I said before, are just y equals x. They are linear lines, meaning they are straight lines. Straight line would look like this. Anytime it's a negative slope, then you know it's going down. So you know these two have negative slopes. This one has a positive slope. So you know right away that this one is C because it's going up 3, right 2, and it also has a y-intercept of 2, which means it starts at 2, and then it goes up 3, right 1, up 3, right 1. This one's going down 1, right 1, so this one's got to be A, down 1, right 1, down 1, right 1. The slope is negative 1. It has a y-intercept of 0. And this one has a y-intercept of 4, meaning it starts at 4 and it goes down 2, right 1, down 2, right 1, down 2, right 1. M for slope, y equals mx plus b, is the general format. M basically tells you how fast the graph is going up or down, and B tells you where it starts on the y-axis, had the slope been 0, basically. We have quadratics. That means when x is squared. There's multiple ways of writing this. There is standard form, and then there's vertex form, and then I feel like I'm missing one. There's another one. Oh, that's all I can think of for right now. Key features. So the vertex is your HK. So this tells you translations, whether it went left or right or up or down, and the A. And you'll notice that it's basically kind of the same thing for all functions, that the inside of something is always the left or right, and the outside of something is always the up or down. So this is left 2, up 4. Left 2, up 4 will be like this one, and you know it's facing down because And that's what happens. I keep touching my touch screen. This negative tells me that's going down. So this one's definitely A. B, this was left one down 4, but it's facing up because A is 1, so this one's B. Right one down 4 is this one, and it's also facing up, so this one is C. Polynomial functions. Polynomial means that you have a degree greater than, well, actually it just means there's a degree of anything, but usually you refer to polynomial functions as ones that have a degree greater than 2. Or greater than 3, I should say, because 3 is cubic, 4 is quartic. Okay, so anything higher than that, so you're dealing with 5, 6, 7, 8, 9, 10. So you're looking at a degree that's the highest right here. So we have talked about in previous videos how the end behaviors, if it's an odd degree or if it's an even degree. If it's an even degree, then both end behaviors will be the same direction. Either both sides will go up or both sides will go down. That's if it's an even degree. And if it's an odd number, which this one is, then one side's going to go up and the other side's going to go down. And it just depends whether or not that leading coefficient is either positive or negative. Now, this one has to have this is clearly not the graph for this one because this one has to have a negative leading coefficient. There would have to be a minus in front. In this graph, so I kind of just answered this question right here. So is this the correct for this graph? No, it's not. And the reason I know it's not is because that leading coefficient should have been positive since its end behavior was going up. The general shape of the function was going up the entire time. Well, not the time in the middle, okay, but for the majority of it. Exponential is when x is an exponent. That's a times b to the, or I use r usually, so r for the rate, to the x minus h plus k format. So this is your y-intercept times the rate to the power of x. That a is the y-intercept, b is the rate, like I just said a second ago. So you can just look at these and you can see, well, if it's a fraction as the rate, then you know it's going down. It's called exponential decay. And if it's a positive number, then it's exponential growth. Now, the only one that's growth is B, so the only one going up is number 1, so this one has to be B. And it's plus 1 because that's the general asymptote right there. They all have, this one's plus 1, this one's minus 1, so that's a clear giveaway that this one is A and this one is C, because the minus 1 tells you that it starts down here, and this one starts over here. And keep in mind, these are going down because they have anytime the rate is between 0 and 1, if that rate right there is some sort of fraction in between, then you know it's going down. Or if it has a negative exponent with a positive number, but I'm not going to get into that right now. All right, we have logarithmic functions. Remember I said before, logarithmic functions have vertical asymptotes. That's the difference between the two. The exponentials... That's the difference between exponential and logarithmic. So this is the format for logarithmic, and generally the way you move a logarithmic is the same as any other function. The h moves it left or right, the k moves it up or down, and the a is your dilation factor. So basically that's going to tell you how fast it's going, how much it's basically stretched is the way of looking at it. So how fast it's going to go up, how much the slope is going to be moving. We've got radical family. So radical is when you have like square root or cubic root. The difference between the two is square roots is the inverse of a quadratic. So when you turn that about like this, it's not going to be a function anymore. So what you have to do is you have to restrict the domain, get rid of one of the sides, and then you have yourself a square root. Whereas cubic root is the inverse of cubed, x cubed. And x cubed looks like this. So if you just turn it, it's going to look like this. Moving on to the next one. So we have rationals. Rationals are like this. So anytime you have x in the denominator, so that means that it's a rational function. It's going to look somewhat like this. If it's 1 over x squared, then you know you're going to have a function that looks sort of like this. That's the only thing that you don't see over here. So this is 1 over x, or actually this has been translated. It's been translated right 2, and it's also been translated up 1. So this moves it left or right, and this moves it up or down, just like every other type of function. Absolute value. If it's inside the parentheses, then it's going to move it left or right, so that's your h. And if it's outside, then it's moving it up or down. That's your k. So it moves just like any other function. Same with sine and cosine. If it's inside the function, it moves it left to right. If it's outside, it moves it up or down. And then anything in front is basically just telling you how big the amplitude is, how far up and down it goes. All right, and I'm going to stop right there. So we've pretty much gone through them all, and then in the next video, you're going to see how you can add and subtract different functions together to get a combination of functions. Thanks again for watching. Have a great